Here's an example of a prioritization matrix to select the process that has the highest priority amongst 4 processes A, B, C, and D. We will use Microsoft Office Excel application to do this. The processes are listed vertically here, while the selection criteria are listed horizontally. The criteria represent the elements or features of the process that will enable us to judge on its urgency for improvement. In this example, we have quality problems, cost-saving potential, cycle time, and frustration as criteria elements. Each criterion is given a score relevant to other criteria elements. The easiest way to weigh criteria is by starting with a 1 as the lowest score. Then score other elements as multiple of it, according to importance. For example, if cost-saving potential is given 4 points, while quality problems is given 1 point, this means that cost-saving is 4 times as important as quality problems in the selection process. The same goes with weighing processes. Each process is weighed in terms of the degree it satisfies each criteria element. If process A scores 2 points in having quality problems, while it scores 1 in the level of frustration of workers, this means that process A results in twice the impact in quality problems compared to the impact of level of frustration. It is a good practice for easy reference in Excel formulas to give names to the ranges of calculation. So, I'll give the criteria weights range the name of criteria weights, and processes weights range the name of processes weights. To have similar effects of weights in both the criteria and the processes, we can normalize criteria weights and processes weights by converting the values to a range between 0 and 1. One method to do so is by dividing each weight by the sum of weights. Normalization is performed for the criteria row and for all processes weights under each criteria element. Let's first normalize criteria weights. Sum all weights. Here I use the trick of division using copy and paste special values with the values and divide operation. Perform the same normalization on processes weights under each criteria element. So we end up with normalized weights. Now in the second matrix, in order to calculate each process score, we first calculate the score of each process under each criterion, then sum all its scores. The score of each process criterion pair is a result of multiplying the corresponding criteria weight by the process weight. Using the named ranges, this can be performed in a single step. Finally, we sum up each process scores and select the process with the highest score. Here, process C is the first candidate process to be selected for improvement, as it scores the highest amongst others.